This is chapter 19. We're talking about sample surveys, or ways that we can actually collect the data. Before we start, let's review from chapter 3, qualitative and quantitative variables. So a qualitative variable, if you remember, is described with things like words. So like boys, girls, blue eyes, brown eyes. Okay. Whereas quantitative is described with numbers. Now, the reason we care about this is based on whether we have a qualitative or quantitative variable, it's going to affect what way we want to summarize it. So if we're describing something with words, then we summarize with percentages. Now, this won't really come into play here as much as it will in the next couple chapters. If it's described with numbers, then we want to summarize with averages. Now, those aren't the only things that we can use to summarize, but that's what we're going to be doing for the next few chapters. Now, with that in mind, our goal in statistics is to use sample values to estimate population values. So what happens is we have an entire population of people, we want to estimate something, but it's too difficult to find information on the entire population. So instead we use a smaller sample of just a few of those people. Okay. And then what we can do is if we want to estimate our population average, so if we want to estimate our population average, we will use our sample average to estimate our population average. And if we want to estimate like our population standard deviation, well then we would use our sample SD, or our sample standard deviation. And if we want to estimate our population percentages, then we would use our sample percentages. And when I say sample percentages, I mean like if you want to estimate the percentage of people at the job that are females, then we would use the sample percentage of people that were females at this job. So populations and parameters, in order to ensure that the data is collected appropriately in a way that we can actually answer the question, we first identify the population that we're interested in. So the population is the group of individuals or things, whatever it is that we're actually interested in. The parameter is some number that describes a population characteristic. Usually we don't know the parameters. So when I say the parameter, I mean like the population average, or the population percent of, say, people that are females or of blue eyes, whatever it is you're studying. Those would be examples of possible population parameters. So it's some number that describes the population. Now, again, usually it's not feasible to collect data from every individual in a given population. It's too expensive, it's too time consuming. So instead of collecting data on every subject in a population, data is collected for a subset of the population called the sample. So the sample is that smaller group of the population that we actually collect the data on. And a statistic is a value calculated from this sample. So that would be our sample average. Or our sample percent are the ones that we're going to do a lot with in this class. Then what we do is we use our statistics, so we find these numbers from our sample to estimate the parameters. The parameters are our numbers for our population. So we're using our sample statistics to draw conclusions or to infer about our population parameters. So this is called statistical inference because we're inferring. We're using something to find something else. So I have this graphic and I'm staring and thinking I had actually maybe do it the other way. But we have our population and then we take a small sample from our population. The population has some number like the average. And then in our sample, we can also get the average. And then we're going to use our sample to estimate the population. So we draw a sample from our population and we use our sample to estimate the numbers for our population. Now in class, we will actually go over these different examples. So I'll do the first one and then in class we'll do the ones where we actually need to fill things in. So example 324, an investigator wishes to know what percentage of voters in the US will vote Republican in the next election. So the population would be, I'm going to add this keyword here, all. Okay, so it's not always written into every problem, especially when someone else writes it, but the population is usually going to be all the voters in the US. That's what we're interested in. The parameter, the thing we want to calculate, is what percentage of US voters will vote Republican in the next election. So what we do is we take a sample. We can't find all the voters in the US. That would take too long and be too expensive. So she takes a random sample of 100 voters and found that 40% said they would vote Republican. So the sample is the 100 voters that were actually in the sample. The statistic then is the 40% that said they would vote Republican. And so we will estimate the population percent as 40% Republican. We're going to talk more about that later, but our sample is our best estimate of our population. So we'll do this next example in class. You can try it now if you want to see how you're doing. Then this next example we're actually going to do in class as well, because it's an activity for us to do together. We might want to know, is our sample statistic a good estimate of the population parameter? So if we're going to actually take a sample, we want to know, is our sample going to give us a good estimate of our population? So for a laugh, here we go. We had a presidential preference poll in school today and SpongeBob SquarePants won. Okay, obviously silly, but it illustrates if you take a bad sample, you're going to get bad results. Okay, so no one's going to go ask students in a school who's going to win the next presidential election. Okay. However, people still take many bad samples in many different ways that mess up their results. So let's talk first about how would you choose a good sample. So if a sample is poorly chosen, then any statistic you calculate from that sample is going to be a poor estimate of the population parameter. So we need to actually choose samples that are representative of our populations. So representative means that, so right here, so a representative sample, it's like the population in ways that matter. Okay, so we want a sample that is like our population. Because if our samples are representative of our population, then our statistics will be good estimates of the parameters. We want to make sure that our sampling procedures are fair and impartial, because humans should never get to help choose the sample, because no matter how hard we try to be random, we are never good at being random. So humans just always introduce bias. We don't want the humans to be able to choose the sample. We want to use random chance to choose samples. Okay, so here's a few different things called probability methods for sampling. So to make sure that our sample is representative of the population, it should be chosen using probability methods. That means the elements in the sample should be chosen randomly from the population. The ways you could do it randomly, like you could toss a coin, you could put names in a hat and shuffle really, really well. You could use computer-generated random numbers. When probability-based sampling methods are used, the interviewers don't have any discretion about who they interview. So again, we want no human choice. So one method you can do is the most common, because it's the easiest, is a simple random sample. A simple random sample, we'll use this so much in our textbook that they call the SRS. It's selected by drawing at random without replacement from the population. So it needs to be random as well, without replacement. The key part is every member has the equal chance of being selected. Okay, so that's like putting everyone in the hat and drawing out one name. Okay. It is without replacement. It doesn't make sense to like sample the same person twice. That would throw off your numbers. So we draw them out at random. Everyone has an equal chance of being selected. Simple random sampling is really good if it's feasible and you can make it work. So some advantages: it is impartial. There's no human judgment. Everyone has the same chance to be chosen. Okay, and the law of averages comes into play. We can prove a lot of mathematical and statistical things with a simple random sample. One of the things we can do is if we have a large enough sample, then a simple random sample says that the percentage, or average, depending on what we're looking at, of the sample is likely to be close to the percentage or average of the population. So for a large sample, we know that our sample average will be close to our population average. Disadvantages: it can be really expensive. It's not always possible or practical. So like, for example, if the population is all eligible voters in the US, then you would have to first list every voter in the US so you can randomly choose them. It is really hard to actually get a list of all the voters in the US. You would also then have to send interviewers all over the nation, because you need the random sample to be scattered all over the nation for it to be fair. Okay, so you can see how that would actually be much more difficult than it sounds. And so you're not likely to ever get into this. You just have to be able to say, oh, that looked like it was stratified sampling. People that actually design these samples have PhDs in statistics and have taken multiple courses on how to do this. But a stratified sample divides up the population into groups based on an important variable like age, gender, income, and then randomly selects people separately from each group. So for example, instead of sampling 150 people from Logan, we could divide them into 3 groups. We could have low income, middle income, and high income. Then we could randomly pick 50 people from each group. So I try to make a graphic. Here's your low income, and you sample 50 random people. Middle income, sample 50 random people. High income, sample 50 random people. The reason you would do this stratified sample is you're saying, okay, I want to make sure that each of these groups is adequately represented. I don't want to just, by bad luck, get all low-income people or all high-income people. I want to make sure it's fair across the 3 groups, but then you still need to randomly sample within each group. So that's stratified sampling. Okay, and then you have something called multi-stage cluster sampling. Often our textbook will just call it cluster sampling. The way they do this, and this is very common with big fancy polls, is they'll divide the population into regions. Then they randomly select regions. Then they subdivide and randomly select again, and then they keep going. So basically, you select a few groups, break those groups into more pieces, randomly select, and keep going until you get really small. So like when Gallup selects data for a survey, Gallup is the really big company that does the big presidential polls. They divide the country into 4 geographical regions. Okay, so they start here. This is our country. They start here. They divide it into west, south, northeast, south, midwest, and west. Okay. They divide into 4 areas, and then for each area, they randomly select towns. Okay. And then after they randomly select the towns, they divide up those towns into what they call wards and randomly select a few wards to sample. Within those wards, they divide them up in precincts and randomly select some precincts. And then within there, they divide up into the households and then randomly select the households. And this specific one that I looked at, they interviewed everyone in the household. So, multi-stage cluster sampling. You break it up into groups, randomly select groups, and then break it up again, randomly select. That way, they don't have to send people to all these different towns across the country. They have less towns that they actually go to, but because they're randomly selecting everything, like at each step, it removes the human bias. Now, there are many different good random sampling techniques that can be used for different situations. These were just 3 very basic examples. Okay. But in our class, for the rest of the semester, we will only be using simple random samples. Everything we do, you can assume is a simple random sample. Now, here are a bunch of things on how to not take a sample. We have to tell you the bad examples, so then when you see examples like this when you read an article, you realize that it's bad and you don't have to trust those results. So this is a famous example. In 1936, the Literary Digest took the largest sample ever, 2.4 million people, and they predicted that Roosevelt would only get 43% of the vote. But Roosevelt actually won with 62%. This was such a huge deal that Literary Digest went bankrupt after this. Now everyone said, how could this possibly be wrong? They had a sample of 2.4 million people. That is a huge sample. So what was actually wrong? What was wrong is they had something called selection bias, and we will talk more about this bias. So what they did is they selected their sample from telephone books and car registration club membership lists. Okay. The poor people didn't have phones or belonged to these clubs. So the survey only had rich people that had the books, the telephone numbers, and car registrations. Okay, and so the survey surveyed richer people, and the richer people were saying they were voting for Landon. But when the poor people went to vote, a lot more of them voted for Roosevelt, but they weren't in the survey, so their numbers hadn't been counted. So this is something very important you should memorize. Not word for word, but the idea. Because we had a bad selection process, taking a bigger sample doesn't help us at all. We have to make sure we have a good sample. Otherwise, how big it is doesn't matter. They also had something called non-response bias. So it's another type of bias where they mailed questionnaires to 10 million people, but only 2.4 million responded. So often people who don't respond are actually different than people who do respond. We've found over the years that people with negative opinions are usually even more likely to respond than people that have positive opinions. So we've mentioned a few types of bias. Here's several types of bias that you could be tested on. There are, depending on what textbook you read, they might have different names for them. They might combine some into a group. Some might add on a few more groups. But these are some basic types of bias that you could see. So bias is any systematic error in an estimate. So if you remember back in chapter 6 when we were measuring, like say we were taking someone's weights, we said you might have a bias because everyone had their shoes on. Okay. So that would be some kind of like measurement bias. There's other types of bias though. So we've already talked about having a random sample. Having a random sample can help reduce selection bias, but there's other types of bias we can still have. So let's summarize everything. This is a quick summary and then we'll go into each one in depth. So selection bias is when you have a bad way of picking people. Response bias is people think that they need to respond a certain way. Again, we're going to go into each one in depth. Non-response bias is of the people you try to survey, some say no, or you can't reach them, like no as in they don't take the survey. Measurement bias is a flaw in the question that influences the results. And really, measurement bias and response bias often are kind of mixed. It's hard to decide which one you should attribute it to, and we'll talk about that. And then volunteer response bias. Instead of contacting people, you let people volunteer to be in a study, and that can really mess you up. Okay, so now let's go into them in depth. Selection bias, that's when you have a bad method of picking a sample. So like some groups and populations are left out when choosing the sample. Like if you go to people's houses, well then you leave out the homeless. Or if you go to people's houses, then you leave out everyone in a hospital. Okay. Or we talked about how we only found the people that had telephone numbers. Okay. Now, selection bias often happens if there's any human judgment picking a sample. It also happens if we pick samples because they're nice and easy instead of doing a really good probability sample. So, for examples, in 1936, samples for predicting the presidential election were chosen using telephone books. The poor didn't have telephones, so there was a bias against the poor. Now, in class, we'll do 334 and 335 in class together. Then response bias. This is when people are not honest, okay, because they think they need to answer a certain way. So, for example, subjects might not want to answer sensitive questions honestly. Okay? So if you think about something that might be embarrassing to them, they might not want to answer honestly. Anonymous surveys can sometimes help with that. Sometimes we have issues with what we would call talk is cheap. So what people say and what they do are often different. So I might say that I'm going to volunteer in my child's school every week, but then life gets really busy and work gets busy and it might not happen. Okay. Sometimes they change their mind afterwards. Sometimes subjects are influenced by the interviewer's race, gender, age. This is often subconscious, at a subconscious level, but we have found that it is real, like we can measure how much they're influenced by the interviewer just subconsciously. Okay. There's also interviewer control. So like subjects are trying to please the interviewer by giving answers they think they will like, or the subjects are afraid of giving honest answers. So in this comic, the king is conducting a survey. How do you feel about paying taxes? Okay. Well, this person is surrounded by the king's guards looking ready to maul him, and he says, oh, I can't complain. He's afraid of answering honestly. That would be response bias. They're not honest. Measurement bias is something is wrong with the actual survey, usually like a bad question. So questions are phrased so that people are more likely to pick a certain option. They're leading questions. So given two options, if people don't have an opinion, they often also pick the first option. So sometimes what they'll have to do is they give some people one survey that has all certain options first, and then they give half of the people a different survey that switches the order of the answers, just because, again, if they don't have an opinion, they pick the first option. Sometimes the questionnaire has loaded words or ambiguities. We found a lot of times people don't actually understand the vocabulary, and so they don't know how to answer. Or sometimes the interviewer isn't well trained and they accidentally give cues of how they want the people to answer, things like that. So, for example, a city wants to survey citizens about the need for a better public transit system in the city. Which of these two questions would give less biased results? Okay, so the first one says, since cars pollute the environment, do you think there should be a better public transit system in our city? Or the other option is, do you think there should be a better public transit system in our city? So this first one, notice, since cars pollute the environment, okay, this is leading It's telling them that you think cars are bad, and it's telling them they should vote yes. Like, how is someone supposed to read this question and vote no? Okay, you can only do that if they say, I don't care about the environment, basically. And so this is a leading question. This is a bad question. Okay, so, but just, do you think there should be a better public transit system in our city, would be a better question. Now, even that might still be leading. It would probably be best to actually just say something like, how do you feel about our public transit system? And then you could give them options of, I think it is doing great. I think it's okay. I think it needs to be improved. That would be more fair. Even this one would still be slightly leading because you're saying, should there be a better? You're saying like, oh, I think I should improve it. Don't you think we should improve it? Okay. But that first one is definitely a leading question. Then non-response bias is caused when you have picked people to be in your sample, but you can't reach them or they refuse to respond. We found that there's important differences between people who respond and those who don't. So lower income and upper income people usually don't respond to the questionnaires. So the middle class is actually overrepresented. Also, if you interview people at home, women are more likely to answer the phone. Now, some of these things might be slightly out of date. That might not be as true anymore. Also, people who are not at home when the interviewer calls might be different from those who are at home. So like if people are working, they're not at home during the day. Okay, maybe based on their age, like retired people are home in the day. Okay, things like that. So again, non-response bias is you've already picked them, but you can't reach them or they refuse to respond. Volunteer response bias is caused when you let people volunteer to be in the study. This can include things like mail-in surveys, click-in polls. Basically, the people decide that they want to be in your survey. Volunteers often respond differently than the general population. So people who feel strongly towards an opinion are more likely to volunteer to do a study. They're even more likely if they have negative opinions. And people who are really busy are less likely to volunteer to fill out the survey, of course. And the people who are really busy might feel differently about the issue than the general population too. So here's a comic. It says, we received 500 responses and found that people love responding to surveys. Okay, so for the people that responded to the surveys, 99.8% said, yes, I love responding to surveys, and 0.2% said, no, I toss them in the bin. But the problem here is the only people that responded to the surveys are the people that love surveys. So of course, everyone said they love surveys. So a question might be, are bigger samples better? Well, if a sample is representative, then a large sample is better than a small sample because it gives more precise estimates of the population parameter. But if the sampling procedure is biased, then taking a large sample does not help. Okay, it just repeats the basic mistake on a larger scale. It just makes it worse and worse and worse as you get a bigger sample if you have a bad sampling procedure. So here are some specific types of bad samples. In 1948, Thomas Dewey ran for president of the United States against Harry Truman. 3 different polls all predicted that Dewey would win the election, beating out Truman. But Truman won by about 5 percentage points. Okay. It was a huge deal. I mean, they'd already printed off newspapers. Huge deal. And they went back to study and said, why was this wrong? Why didn't it make sense? So these polls use what's called quota sampling. The interviewers were required to interview a certain number of people in several categories, such as residence, age, and sex. The interviewers could select anybody they liked as long as their subjects satisfied the specified criteria. So for example, in St. Louis, let's say they had to find 13 people to interview. And they'd have various criteria that they had to make everything match into. So they needed like 6 in the suburbs, 7 in the city. But of that, they also had to make sure they had 7 men and 6 women. They needed 3 under 40, 4 over 40, 6 white, 1 black. And on their monthly rent, they also had to make sure that like 1 was paying a certain amount, 3 were paying a certain amount, and 2 were paying a certain amount. Now, it sounds like a really good way to make sure the sample is representative of the population. So they looked at the population. They said, oh, like 6 out of every 13 live in the suburbs, 7 out of 13 live in the city. And they wanted to make sure the sample was like the population. So it sounded good. Okay. But it turns out that there's way too much room for human choice. And that human choice leads to bias. So human choice leads to bias. The interviewers somehow consistently chose too many Republicans. Now, maybe that was because the pollers themselves were Republicans. So maybe when they were walking down the street, they found people that they're like, oh, he kind of looks like me. I want to go interview him. Okay. There are many factors that affect the way someone will vote for which the pollsters didn't have a quota. So like we tried to break it up, but there were still other things that could affect how they want to vote. But inside the categories, there's a lot of room for human choice, and human choice leads to bias. So maybe the Republicans were easier to interview for some reason. So that was an example of quota sampling. So in quota sampling, the subjects are hand-picked to resemble the population with respect to some key characteristics. It seems reasonable because it makes sure that the sample resembles a population in respect to like some important characteristics that we think would matter. But quota sampling does not work well because of usually unintentional bias on the parts of the interviewers. So again, having human choice leads to bias. So if the humans get to choose who to sample, it messes up our results, even if we think we're doing a good job of it. Then we have convenient sampling, not a good choice either. That's when subjects are chosen because of their convenient accessibility to the researcher. So this includes also if you let people self-select to be in the study, so like mail-in surveys, click-in online polls, those would all be people are self-selecting. So the subjects are selected just because they're easiest to recruit for the study. Convenient samples are almost never representative of the entire general population. So for example, if I want to estimate the percentage of all students on campus who have taken calculus, I use everyone in this class as a sample. Do you think that estimate is going to be accurate? Do you think the sample is representative of the population? So we'll go over it tomorrow too, but just here quickly, what do you think? Okay, and the answer is going to be no, because people in this class, they take this class usually because it doesn't require calculus. Okay, and so if you're not going to take calculus, I would bet almost no one in this class is taking calculus, but that's not a fair representation of the entire campus because there's a lot of people that take other math classes that do require calculus. So in summary, the method of choosing a sample matters a lot. Okay, the important features for what we want is we want probability methods, random samples. We want interviewers to have no discretion as to who they interview. So we want no human choice. We want to have a definite procedure. Like we want to plan this out in advance, have a plan. A good plan. And selecting the sample involves the planned use of chance. We want to use chance, so we're not using human choice. Now, sadly, even when we use probability methods to select our sample, the estimate of their parameter will still be different from our true parameter, just due to bias and chance error. Mostly chance error. We try and get rid of bias, but there's still always chance error. So we're hoping we get a good estimate, but our estimate's still going to be off, at least by a little bit, sometimes by a lot, just due to chance. How accurate our estimates are likely to be is what we're going to study in the next few chapters. And this one is worth memorizing. If you use good sampling techniques, then bigger samples are more accurate. If you use good sampling techniques. So that is our chapter. In class, we're going to go over all those examples, and then we'll go over all the extra examples.